Before we begin to talk about double displacement reactions, we have to talk about solubility. Solubility is the ability for a substance to dissolve in water and form a solution. This is not to say that a compound cannot be soluble in anything else. You can have compounds that dissolve in other things, but for all our purposes, we're just going to look at the ability to dissolve in water, and really now just for ionic compounds. When you dissolve something in water, most of the time you get a clear solution. So in this case, we put hydrochloric acid in water, and you can't tell that there is hydrochloric acid particles in here. That's what a solution is. It looks the same throughout. It's homogeneous. So the hydrochloric acid is dissolved. In other cases, especially when we have transition metal ionic compounds, we can get colored solutions. So we started with water, we added our ionic compound, it dissolved, and it changed the color of our solution, but it still looks the same throughout. But what does it actually mean for a substance or an ionic compound to dissolve? So this video will help us explain that. Remember that ionic compounds, in this case sodium chloride, form crystals, repeating patterns of positive and negative ions. As you watch this video, watch what happens as the salt crystals fall from the shaker and into the water. So the crystals are really nice and tight and packed together, and when they hit the water, notice that the positive sodium ions, the red ones, and the negative chloride ions separate from each other. And this is actually why you don't see the salt anymore when you put it in water. The ions, the crystals, separate into the positive ions and the negative ions and spread out throughout the entire solution. Well, but why does this happen? Why are these crystals pulled apart? Well, remember when we talked about molecular compounds such as water. So I have my water molecule, and water has a slightly negative end, and a slightly positive end. So it is polar. One end, the oxygen end, is more electronegative. It gains a slight negative charge because the electrons are pulled more in that direction, leaving the other side with a slight positive charge. Now, because water is slightly charged, its negative end is going to attract the positively charged sodium ions, and its positive end is going to attract the negatively charged chloride ions. Now let's watch what happens on the molecular level when we put salt into water. So this is the molecular view, and watch what happens to the sodium ions and the chloride ions as the salt is dissolved. Note that the big red part of these molecules is oxygen, and the smaller white parts are the hydrogens. So the sodium chloride goes in, and you can see that the water molecules pull that crystal apart. Notice how around this sodium you have the negative oxygens are all facing it because the negative end is attracted. Now watch the chloride ion, and you can see that the positive ends, the hydrogens, are facing the chloride. And again, the negative ends are facing the sodiums. So ionic compounds dissolve because of this attraction between ions and the polar or dipole water. And if a salt is able to dissolve, we call it soluble. If a substance is soluble and our reaction is taking place in water, the state is aqueous. But is it possible for an ionic compound not to be soluble? In this video, I have a salt that is what we called insoluble. So we're adding the salt crystals, and as you can see, the majority of the crystals stay together. Now you'll notice that there are a few ions that are separating. That has something to do with what's called equilibrium, which we'll get to later in the year. But the fact that most of the salt does not dissolve means that the strength of the bonds that hold the positive and negative ions together are stronger than the bonds that water would make with the ions. So the water is unable to separate that ionic compound. A compound that does not dissolve in water is called insoluble. And in a chemical equation, it's going to be solid as its phase. This is an image of a salt that is insoluble. This is lead iodide, and as it's added to the water, you can see that it remains solid. It's not mixing throughout the solution. If we let this sit for a long time, all of the lead iodide would end up sitting at the bottom of this test tube. So now that we know what it means to be soluble, how do we tell if an ionic compound is soluble? Well, fortunately for us, there are some solubility rules. If read carefully, the solubility rules are really easy to follow. So the rules are nitrates, acetates, and chlorates are soluble. So if you have a compound with a nitrate ion, acetate ion, or chlorate ion, it's going to be soluble. For example, sodium nitrate would be soluble. Number 2, salts of alkali metals, group 1, and ammonium salts are soluble. That means if your metal ion, such as in this case, sodium, is in group 1, whatever salt you have will be soluble. Most chloride ions, bromide, and iodide salts are soluble, except with lead, silver, or mercury. So that means that something like lithium chloride is soluble, but if I had lead chloride, this is insoluble. So lithium chloride will dissolve in water, lead chloride or lead 2 chloride will not. Number 4, most sulfates are soluble. So if you see SO4, the sulfate ion, it would be soluble except if there's strontium, barium, or lead as the metal. All hydroxides are insoluble. So if you see OH minus on a ionic compound, then it will be insoluble except if you have a group 1 metal, just like it says in rule number 2, or strontium, barium, and ammonium. And lastly, if you have a sulfide, carbonate, chromate, or phosphate on your compound, it's going to be insoluble unless you have an alkali metal. So let's just try one more example. Is this soluble or insoluble? So we will do SrOH2. Well, this is a hydroxide, OH, so we look at our hydroxide rule, and it says all hydroxides are insoluble, except when with group 1 metals, strontium, barium, and ammonium. Well, our metal is strontium, so that is one of our exceptions, and this salt would be soluble.